Alrighty, folks. So we are getting back into systems of equations. So this is just going to be a review of two variable systems. If you don't remember, there are three ways to solve these. It is substitution, elimination, and graphing. So I want you to take a second, see if you can remember how to solve by substitution first, and then I'll go through it with you, and then I'll have you try number 2A, and then I'll have you try number 3. Same thing. So pause the video for a second. See if you can try number 1 by solving by substitution. If you don't remember, just keep watching. Okay, so we are going to start by substitution, meaning we are going to solve for a variable and plug it into the other equation. Okay, so easiest variable to probably solve for is x here, so I would say x equals y by adding the y to both sides. Knowing that, I can literally plug that in for the other equation. So I know that x equals y, so this turns into 5y minus 3y equals 6, or you could plug in x for the y and you get the same thing. Simplify, so we get 2y equals 6, divided by 2, so y equals 3, and then plug that in for either equation to solve for x. Now, what's nice is I know that x equals y, so my coordinate for my solution is 3, 3. Okay, so try number 2A, see if you can remember how to solve by elimination. Same idea, but this time you're going to have to eliminate a variable. So pause the video and I'll show you how to do it after. Okay, so in this case, I just have to add the equations together and that cancels out my y's. So I end up with 2x equals 6, so x equals 3 again, weirdly enough. Plug that in for either equation. I'll plug it into the x plus y equals 4. So I get 3 plus y equals 4. Solve for y. I get y equals 1. So my answer, you write it as a coordinate, because technically a system is two lines that are intersecting. And you find the solution by figuring out where they intersect. So my solution would be 3, 1. Okay, so try B. Take a second and see if you can get it. Again, pause the video if you get a chance. I will show you how to do this. This one's a little bit more complicated, but if you are struggling, I will show you how to do it in a second. Okay, so by eliminating, it means you want to cancel out a variable. There are a few different ways you can solve this one, but the easiest is because the y's are already opposite signs, I'm actually going to multiply those by something that'll cancel each other out. So the number that works for both 3 and 4 that I can get and get the same number is 12. So I want to multiply this whole equation by 4 and the bottom whole equation by 3. Make sure you distribute to all the terms, so that'll give me 20x plus 12y equals 36. Okay, and then the bottom equation would give me 6x minus 12y equals 42. Okay, so 14 times 3 is 42. Then, now if I add the equations together, that gets rid of my y's. I get 26x equals 78. Divide both sides by 26. So 78 divided by 26 is 3. So x equals 3. This seems to be a theme on these questions. And then plug it in for either equation. I'm going to let you finish that part out. But I am going to plug it into the top equation. So I would get negative 2, it looks like. So you end up with 3, negative 2. It's weird that those were all 3's. All right, last type is solving by graphing. And we're going to solve one of the equations by graphing and hopefully get the same answer. Let's use A. Okay, so I'm going to rearrange letter A so that I can actually graph those. So the x plus y turns into y equals negative x plus 4. You're just subtracting x on both sides. And then the other equation, I get negative y equals negative x plus 2. So you have to divide everything by negative 1, and you get y equals x minus 2. I'm sorry I'm going so quickly, but you guys learned this a few years ago, and now we're graphing. So we end up with both of these graphs. I'll graph this one in black and the second one in red just so you can see the difference. So my first equation, I start at 4, I go up 1 over 1, but it's a negative slope. So my line looks like that. Hopefully you guys can draw a straighter line, use a ruler. And then the other graph starts at negative 2, but goes up 1 over 1 to the right. Okay, and if you look at the equation, my line is a little bit off on the top one, but they actually do intersect at 3, 1. Again, you could be more accurate with a ruler and hopefully see that they actually intersect at 3, 1, which matches our answer from when we did it by elimination. Okay, last question on this front page is, it says a total of $12,000 is invested in 2 funds, paying 5% and 3% simple interest. The yearly interest is $500. How much is invested at each rate? Okay, so we have to set up a system of equations here. So our first equation is going to be a total of $1,200 is invested in 2 funds. We are going to call those funds X and Y, right? So this is Fund 1, Fund 2, right? The yearly total interest is $500, so we're not going to deal with the actual interest until we already figure out our first equation. We're just going to say we're adding those 2 funds together to get $1,200. Or sorry, $12,000. Then from there, we can say I'm going to actually take 5% of my first fund and add it to 3% of my second fund to get my total interest of $500. Now it becomes a very standard equation. I'm going to have you take a second. You can choose to solve this by elimination or substitution, and pause the video and I'll have the answer for you in a second. Okay, so you should end up with Fund 1 is 5, oh, that's not true. It is not 500. It is 7,000. That is not your bell. And then Fund Y, or the second fund, is $5,000. Okay, and you can actually look at that as money, so add yourself some symbols there for money. Alright, so these are a little bit more complicated because they have squares in there. It's actually going to be a lot easier if you solve by substitution here. So we're actually going to solve for one of our equations and then plug it into the other. So let's start with this first one. So I'm going to solve for y here. It's just easier. So I'm going to say negative y equals negative 2x minus 1. Okay, so you end up with y equals 2x plus 1. So then you can substitute that in for the other equation. So I got x squared plus 4x minus, make sure you put parentheses around that whole expression, 2x plus 1. So I'm literally taking that and plugging it in for the other equation, and that equals 7. And then you can simplify. So you have x squared plus 4x minus 2x minus 1 equals 7. Move everything to one side, factor, and then you can solve from there. So we want to get everything over to the left, so you get x squared plus 2x minus 8 equals 0. Solve for your 2 factors. So you get x minus 2, x plus 4, x equals 2 and negative 4. But then you have to check, you have to plug both back in. So I would plug them into that second equation. It's a lot easier to plug in for, but you have to plug in for both. So your 2 solutions, I'm going to have you take a second, pause the video again, plug them back in, and you end up with 2 different coordinates. Okay, so you end up with 2, 5, and then the other one is negative 4, negative 7. Okay, I'm going to have you try number 2 on your own. Again, pause the video, and I'll have you solve it, and then when the video is unpaused, it will be solved for you. Okay, hopefully you recognize like this comes out to be weird. You can't factor it. However, you can use the quadratic formula. So if you try to use the quadratic formula, you end up with negative 1 plus or minus square root of 3i over 2. That would be no solution. okay, because you can't end up with an imaginary root. Okay, so that would end up being no case. If you calculate something and you get infinitely many solutions, what that would look like algebraically is you would get like x equals x or like 3 equals 3. Visually, what that looks like as a graph are two lines that hug each other. So it ends up being the same exact equation, okay? No solution. You'd end up with like 3 equals 2 or like 0 equals 5. And visually, again, think about graphically what no solution would look like. They're parallel lines, okay? So if you graph parallel lines, they would not have any kind of intersection. Okay. The last type that I really want you to do is solving by graphing in your graphing calculator. What I'm going to have you do is graph these out. If you don't remember where the ln button is, it's right above store or right below log. Graph both, and then if you find the solution, it's the intersection. If you don't remember how to do this, come and see me, and I'll work through it with you. But I want to see if you can try to do this without my help. And I'm going to check that answer on, when do I see you guys next? Thursday. Okay, so do out number 5. I'm going to have you finish that on your own, and again, I'll check the answer on Thursday. Number 6 is not graphical, but they show you graphically as well. This is just another system word problem. So they set it up so that you're doing cost and revenue. Cost is when you're charging people something. Revenue is what you're actually getting back. So profit is actually going to be cost minus revenue, because you end up figuring out how much money you're going to total make in the end. They figured out that if you sell 18,182 bottles, that's where the break-even point is, basically where you stop having costs and instead you're just making straight revenue. So that's just a visual for you right here, and then you also have the actual math right next to it. All right, so if that is it, then you are done. Have a great rest of your day, and I will see you on Thursday.